Alright, so now we're going to be doing a test of Explorator Clapper, which, when this was initially designed, it was for a specific group of exhibitions in the American Southwest. Very arid, dry environments. There wasn't any expectation of rainfall, so it was minimally protected from environmental conditions. Since then, since this initial in-situ testing, there's been a few modifications to the enclosure, including the application of silicon sealant in a few sort of critical spots that aren't where just simple kind of water protective washers and flathead screws are not going to necessarily guarantee you ingress protection. Plus, this artifact was created when there's no access to manufacturing tools such as laser cutter. So because of that, it was made out of parts that were laying around from old projects. So, without further ado, it's going to be subject to the same testing conditions as all other artifacts. We've got just under 7 liters per minute of water flow, about 45-degree angles. You're going to be susceptible to this test for 10 minutes, and this is meant to simulate torrential rainfall, kind of the most intense conditions that you would expect normally if installed in an outdoor natural environment. And what we're testing to see if any liquid enters into this enclosure so that we can give it some sort of a approximate ingress protection rating. So, let's go. Good amount of water with a decent pressure. It's a good shower. Like I said, we're looking at just under 7 liters per minute. Great. So, final step. I almost forgot. Setting our timer here. A little bit late, but we just have it started. It's going on my phone. I'm going to leave the camera rolling and check back in 10 minutes and see what. Alright, there you go. Just restarted the video. Now I'm going to turn off the shower. Probably the camera can only record like 15 minutes of video at a time. Alright, anyways, we got that turned off. I'm going to hop on in here and take a look at what we have. So, a little bit of water pools on the top here, which is something that these acrylic enclosures experience pretty often. I think future enclosures, what I'm going to do is I'm going to round off the edges right around here to allow the water to seep down and off, so that can be part of my future work. Alright, excellent. So, and then on the bottom, so you can see we have this very thin plastic film, which is essentially a few films of thin tape, which are then have silicon sealant around them to allow the lux sensor to maintain its ability to collect accurate readings, while also at the same time protecting these electronics. Oh my gosh, there is a screw just completely missing. From this connector right here. So that is obviously a problem, and that's probably would have resulted in a little bit of liquid ingress. Which, as I'm wiping this sucker down, I do see a teensy bit of water inside this enclosure. It is so small. It's like a drop. Yeah, we got like about a drop of water down there. Now, the origins of it is a little bit less clear. It's possible it could have all originated from our lack of a screw there. It is unlikely we would get. I can't even see it anymore. I moved it that much, so fortunately we have to say that our little friend's. Oh, I see a huge possible problem. We have a structural integrity issue with this bit of the enclosure. Yeah. So usually these outside rings are bonded to the top plate using sealant, and it looks like I somehow forgot to do that on this guy. So what we got to do is we have to patch this sucker up, and then I can see that the water is coming in from there. So we have a mistake on my part that caused this test to fail. Bummer. Wow. Alright, gotta move on to the next one.